Testing regular software is a bit like this. You call a function and you check if the output matches what you expected. But testing an AI system is a little different. By this time, you guys know it. A lot of what it produces does not have a single right answer, right? Our particular bot is three distinct things. It routes messages to the correct agent. So that's one. The crop disease agent gives a structured reply based on certain things. And the farm strategy agent talks in a more conversational manner. So all these three will require a different evaluation technique. And we are going to build one each for this farm advisory AI. So let's get into it. The first is a code grader, right? It's a binary pass or fail. And there's like a right answer here, which is how is the message routed, right? Either it was routed correctly or it was not. So that's binary. And I already ran this, and this is the result that you see over here, where we have these 10 questions. The second is a logic creator. No AI calls, no cost, completely instantaneous. It's used for testing decision rules like the escalation we built in the last episode. The third is a model creator. You use a second Claude instance to create the first one's output on a rubric, right? It's used for its open-ended quality, like whether the harvest advice is actually good or it's not. So three components and three graders. So let's see how they are built. So here is our original webhook file that has this function called classify message. Now, this is actually the one that is routing with the Haiku model call and has these clear routes that it can take, classify the message into exactly one of these four categories, which means it has an output that is one string. So we are going to take that call and put it in our test classifier.py, right? All right. So in this particular file, what we're trying to do is we are giving these test cases have greetings, they have off-topic stuff, like will it rain in this region? That's clearly not a crop disease or even a farm strategy question. That is a pure off-topic question because even though we have the weather tool, there's no other context. So we provide the test cases as a constant and we loop through them and send them to the classifier message. And if the actual is the same as what we expect, then we say that is pass. Otherwise, we say that is not pass. It's as simple as that. It prints out all of these with a check mark or a cross mark. Binary pass or fail, no judgment required, right? And those are the results. The test basically makes the bugs visible. The bugs were always there. The code-based grading works when there's a single correct answer, right? Routing is part of that category. But now let's look at something in which that's not the case. And that's a lot of what working with AI is. So now we're going to look at the escalation. In last episode, we built an escalation path, right? High severity and reviewer concern together trigger the escalation message. But our test file doesn't test that. It tests routing, right? The escalation fires after routing, which means one of the agents has been assigned the message. They run, and then the agent runs after the reviewer runs. The current tests will not reach it. So that test cannot be used. And we now need to, as a fix, pull the decision out of the handler into a function that we can test directly. So what we've introduced in webhook.py is a new function called should escalate, right? It returns true when both the conditions for escalation are met, which is the severity and the concern. Now, what this does is we can test the logic without making any API calls, which saves cost and is probably faster too. Test escalation.py runs 4 cases. First, high severity with a concern should escalate, returns true. Second is a high severity with no concern should advise normally, returns false. The third is medium severity with a concern by that independent agent and returns false. And fourth is low severity with no concern. Advice normally, this is day-to-day work, returns false. So let's run that one live. So we have 100% result, 4 out of 4 are passed. The correct factors in severity and in concern. Now, what this does not test still is whether the crop disease agent actually assigns high severity when it should. Because I know what you're thinking. You just did this from what it already is, but we don't know why it assigned that kind of severity, right? So now we come to the third one, which is model-based grading, where we use a model to grade the results of another model call. This is the hardest thing to test. Is the advice any good or not? There's no single right answer to should I harvest my groundnuts this week, right? And it could be a number of different cases for different industries. The response could be technically valid, grammatically fine, and still give bad advice for this farm or for your application for a very subjective topic. So this is where we will use a second Claude instance, which is a grader, to evaluate the first one's output. You give it a rubric and you ask it to score the response. So let's go ahead and do that. So first, the data set here, 3 farm strategy questions, one about harvest timing for a 115-day-old groundnut, one about irrigation timing for onion, and one about crop rotation from groundnut to cotton. Each question has a rubric, a description of what a good answer looks like. Here are those, right? So we make that call, we give in the information, and essentially we make a call that is very similar to any other Claude call. Then comes the grader function. The grader gets the question, it gets the rubric, gets the response from the model. And critically, we ask for strengths, weaknesses, and reasoning, right? That is not just a score, it's very qualitative as well. So if you only ask for a score, Claude will default to the middle, and then it's pretty much useless. It's all averaged out. The grader returns a score from 1 to 10 and a 1-sentence reasoning, and it uses Claude Haiku for cost efficiency. And the third is the runner. For each test case, call the strategy agent to get the bot's actual response, and then pass it to the grader, right? Print the score and reason. So that's your main. All right, so let's go ahead and run that. Eval strategy.py. Now, if the average is below 7, something is wrong with the strategy prompt. We'd have to change it. Change the prompt, rerun, compare. That's going to be the eval loop. Iterate and create again, right? So here's our score. So the 3 answers have populated, and we have an average score of 8.7 out of 10, not bad, with individual scores of 9, 9, and 8, right? So what is that for? The answer directly addresses harvest timing with the specific recommendations, provides multiple practical field tests that a farmer can perform, so on and so forth. That's why it's 9. The second answer is the same. It's basically the model is rewarding it a higher score for directly addressing the issue as well as following the rubric, right? Avoiding generic advice, very specific, and so on. The third question, should I rotate to cotton next season? Groundnut crop, that's a harder question. The AI addresses both rubric criteria well by discussing how groundnut's nitrogen contribution benefits cotton and highlighting soil health, proper residue management, though it could strengthen the soil health discussion with more specific recommendations. So it looks like whatever the answer was, it was a little generic and dinged it by 1. But this is a pretty good score. So those were all 3 of our outputs. And we can look at what we have now. We have the classifier routing that is tested with a code grader, exact match, pass or fail. The escalation logic is tested with a code grader again, but in a different part, pure Python, no API needed. The strategy response quality is tested with a model grader, which is one Claude grades another Claude with reasoning, not just a number, so qualitative as well as quantitative. So each grader tests something that the others can't. Routing has a right answer, logic has a right answer, and the judgment or the quality has no single right answer, and only another model can assess it. This is the eval framework. Every component of the system maps to one of these. The bot now has tests at every layer, but there is still something missing. The strategy agent gives the general regional advice, right? It does not know what actually happened on this farm from the ground this season. Now, that's the same as AI giving advice for a construction project without knowing the ground reality of the pictures and the Gantt charts and stuff like that. How much the agrochemicals overran what the actual yield was, what the margin looks like versus what was planned. At the end of the day, the business has to become more profitable with the investment of AI. So in the next episode, we will give it that data. So thank you and catch you next time.